This video, it's all about a question I get asked all the time, and that question is, what type of cast iron do I use to melt, and should I look for special types? Well, I'm going to answer all those questions in this video. Here is a common piece of scrap. It's an engine block. There's a bit of a view around it, and we'll use this as the first subject to discuss this topic. Now, the first thing I do to see whether a piece of scrap is suitable for melting, I like to break off a piece, and here's a suitable piece. Here is that broken piece. It's nice and grey all the way through. There's no chilling, so it's good for melting. Now, before I can melt this scrap, you have a look and zoom in a bit. There is the cam bearing that has to go. In fact, anything that's not cast iron. And then round the back here, we've got the studs and nuts. They have to be taken out. Here is another engine block I'm going to melt down. We'll do a quick walk around. Now, this one here is very dirty, so we need to clean off all that dirt. You don't want to melt down dirt, you just want to melt cast iron. As well as removing the steel studs, the white metal bearings have to go, as they contain lead, and lead mixed in with cast iron, even in small amounts, makes it extremely brittle. As with every piece of cast iron I melt, I like to see the grain structure. So we'll pick that nice piece sticking out in the open, and we'll break that off. This is the broken piece. It's nice and grey all the way through, even those thin sections. That's what I'm looking for, nice grey cast iron to melt. Now, one final word about this engine block, and regards to all engine blocks. This part here is where the water circulates, and it's quite rusty inside. When you melt this, use mainly that and up to about 15 to 20% of this scrap. Don't use all this scrap in one melt, because it'll make the cast iron very hard, but also it makes it very sluggish, like pouring honey on a really cold day. Here is a quick view inside the water jacket, and you'll see just how rusty it can get inside there. Here is a close-up of the cylinder where it's rusted inside the water jacket. It's very pitted, and here I've ground it away. You can see how deep the pitting goes. This scrap is far more useful if you go to a lot of trouble to clean off all the deep rust. But for some people, you may not want to bother doing that. Here is the cylinder head from that engine. I've used an angle grinder to section off a piece, and we'll have a look inside it. This is what the section piece looks like. There's a lot of rust in there, and it can be difficult to remove, but it's still useful for melting down. But have a look at that grain structure. It's lovely and grey. Here is the flywheel from that engine. Now, the flywheel can be very tough to break up because it's thick, so what I've done, I've put in some angle grinder slots and has weakened the cast iron. Here is the fracture from the piece I broke off from the flywheel. It's lovely and grey cast iron all the way through. Very suitable for melting. Here is the next flywheel I'm going to break up. It's from an old farm engine. These are my personal favourite for melting down, as they are thick and chunky and they break easy in the spokes. Here is the fracture. It's a lovely grey fracture all the way through. Very suitable for melting. Now, speaking about farm machinery, it's a really great source for scrap cast iron to melt. And this example here is a hand operated chaff cutter wheel. It's It's about 1 metre in diameter, and there it is, the hand piece where it was hand turned. Here is the fracture from the chaff cutter wheel. It's nice grey cast iron, very suitable for melting. Now all the previous examples of scrap cast iron I've showed you, they have one thing in common. They were melted in a cupola, and they also used pig iron, and this is what pig iron looks like. It's a disgusting looking piece of metal, but it's the most valuable piece if you can find it nowadays. In Australia they don't make it anymore, but this cast iron it comes in very many grades, and it's very soft, and that's why the previous scrap cast iron I've showed you is the most valuable cast iron you can find, but it's also getting harder and harder to get hold of. This is the next casting we're going to have a look at. It's what I call decorative cast iron, and this iron is made from high phosphorus, high carbon pig iron, and it's very suitable if you're going to make model engines, if you want to get the cast iron to flow into very tight spaces and flow a long distance. Here is a broken piece. It's lovely and grey all the way through, very suitable for melting. Here is a very common type of scrap. It is sewing machine scrap. It's very easy to get hold of and gives you very soft cast iron, as I've used this many times in the past. Here is a piece of scrap broken off the sewing machine. It's grey all the way through, very suitable for melting. Here is another piece of scrap that's very thin, probably made out of the high phosphorus, high carbon pig iron. It's an old plough seat. There is the symbol there. It must have come off an international plough. This is why you break off pieces to check to see what the cast iron is like. You can see it's getting mottled there. It's sort of half white and half grey cast iron. And it's probably not suitable for melting down. This is the last piece of scrap I will discuss. It's very representative of modern cast iron and how it's made. It's a very tough cast iron to machine and to break up, but it's very easy to get hold of. Every garage has so many of these on offer. These disc brake rotors are not made from pig iron. They are made from steel. And how it's done, scrap steel is melted in an induction furnace, and then carburizer is added to raise the carbon level from steel level to cast iron level. After that, ferrosilicon is added, and then we have cast iron. But the problem is, when you remelt this cast iron down, because the way it's made, it will return to a hard state, so you really have to add ferrosilicon if you want soft cast iron. And now I'll attempt to break off a piece of cast iron. I'll probably show you just how tough this cast iron can be to break up. Here is what the fracture looks like. It is a grey cast iron, but it's a high tensile cast iron, so don't expect it to be butter soft to machine in the lathe or a milling machine.